Hi class. In this lecture, what I want to do is I want to continue talking about the normal distribution, which we talked about in the previous section, but I want to talk about some problem solving with the normal distribution. So some like application problems. So we really only have one objective in this lecture, and that's to solve applied problems involving the normal distribution. And what I'll do is I'll start with an example. So according to the Department of Health and Education, cholesterol levels, okay, are normally distributed. So cholesterol levels for individuals follow this bell curve shape. All right, so for men between 18 and 24 years, the mean cholesterol level is 178.1, and then the standard deviation is 40.7. Okay, so those are two important values to be given, the mean and standard deviation. So what percentage of men in this age range have a cholesterol level less than 239.15? Okay, so pretty high cholesterol. So whenever you're told something's normally distributed, given the mean, standard deviation, and then you're asked for like a percentage of some type, you're going to need to z-score. All right, so compute the z-score for this value that's given, this 239.15. Well, the z-score, which we talked about in the previous lecture, is the data item minus the mean divided by the standard deviation. So you take 239.15 minus 178.1, that's the mean, divide by 40.7, and you get a z-score when you round it, okay, to 1.5. So go to one decimal place, 1.5. All right, so what we must do then is we must find the percentage of men with a cholesterol level less than a z-score of 1.5. So there's this table in your textbook, and I have it linked in the lecture, that gives the percentages as a percentile. So I know my z-score is 1.5. So let me show you on the table. So you're given this table here in your textbook. It's also linked to in your online Blackboard lecture. So you go to your z-score, look z-score, keep going down, z-score, I find 1.5. So a z-score of 1.5 is in the 93.32 percentile. What that means is 93.32% of people are less than that number, so have a cholesterol level less than that. So it's really easy. Just find your z-score and then find the corresponding percentile. Okay, so thus what we saw, we found that 93.2. So thus 93.32% of men between this age of 18 and 24 have a cholesterol level less than this 239.15. So it's really just calculating the z-score and then looking up the percentile and changing it to a percentage. Okay, so now let's talk about finding the percentage of data items between two given data values. Okay, so finding the percentage of data items between two given items in a normal distribution is done by the following. First thing you're going to have to do, convert each given data item to a z-score. All right, z-score is always the data item minus the mean, divide by the standard deviation. After you do that, you're going to use this table right here, this table 12.16, to find the percentage corresponding to each z-score. Okay, so now you're going to have two percentiles. Then all you're going to have to do is subtract the lesser percentile from the greater percentile and attach a percentage sign. So to find the percentage between two data values, okay, just convert each two to percentiles, then subtract the two. Okay, so let's do this one. The amount of time that self-employed Americans work each week, all right, is normally distributed. Okay, so it follows the bell curve with a mean of 44.6 hours and standard deviation of 4.4 hours. Okay, so mean and standard deviation. All right, normally distributed, also important to be given. So what percentage of self-employed individuals in the United States work between 37.4 and, wow, this is crazy, 80.6 hours per week? All right, so remember, I want to find the percentage between two. So step one, the first thing you're going to do is you're going to convert each given data item to a z-score. So here are those z-scores for the corresponding values of 37.4 and 80.6. Okay, take the data item minus the mean divided by the standard deviation, round to one decimal point. So it's minus 0.5 for this one. Someone who's working 80.6 hours, their z-score is 2.5. All right, so this is important. You do not subtract the z-scores. Okay, do not subtract the z-scores. The next thing you do is you look up the two values on the table. So the percentile corresponding to negative 0.50, going back, negative 0.50 right here. Boom, 30.85. Got it right there. So I've got the 30.85. That's the percentage of people who work less than 37.4 hours. So the table shows that the percentile that corresponds to the z-score of 2.5, again, 2.5, 99.38. This means that 99.38 of self-employed Americans work fewer than 80.6 hours. So now what you do is you take this percentage and subtract it away from this percentage. Okay, so subtract the lesser percentage from the greater percentage and attach a sign. So you take the 99.38 minus 30.85, you get 68.53. So thus what we're able to say is that 68.53 of self-employed Americans work between, this is crazy, 37.4 hours and 80.6 hours per week. All right, so this is just a summary of how you answer different problems. Okay, so if you're asked to find the percentage of data items less than a given z-score, all you do is you find the z-score, look up the value on the table, and add a percentage sign. Now here's the thing. If you're asked to find the percentage of data items greater than a given data item, okay, here's what you do. You find the z-score, and then you're looking for greater than. You subtract the table percentage you just found from 100%. So if it's greater than, you do 100% minus the percentile. If you find the percentage of data items between two, again, just find the two z-scores, look up the two percentiles, subtract them, and add a percentage. All right, thanks, class.